Okay, so this is the continuation of going over the review for Algebra 1 Chapter 4. So this question asks us to use the data over here in this example. So it says to use a calculator to determine the equation of the line of best fit. So when it says the line of best fit, we know to go in our calculator. We're going to follow our notes where we did linear regression and how to do the line of best fit. So you are going to take a graphing calculator. You're going to press Stat and hit Enter on Edit. That gets you to the list. Now to clear the list of whatever was in it, you use the up arrow so that this L2 is highlighted and hit Clear, Enter. And then go over to L1 so the L1's highlighted and hit Clear, Enter. And then you type your data in the list. So you're going to type your data in this column for X in list 1, in this column for Y in list 2. I'm going to pause the video and type my data in. Why don't you do the same? Okay, so this is all of my data typed in. I went ahead and double checked and made sure that list 1 and list 2 are correct. One small typo can really throw you off, so it's worth a quick double check. So now I follow my instructions and it says to go Stat, use the right arrow to go over to where it says Calc, and you want to go down to number 4, which is linear regression. You can go down to 4 and hit Enter, or just press 4 on the keypad. It should say L1, L2. Go down to Calculate and hit Enter. Okay, so this is my equation, and yours may or may not have the R value showing. So this is my equation. I'm going to go, and my A is my slope. I'm going to round that off, and my B is my y-intercept. My R squared we don't have a meaning for yet, and my R is the correlation coefficient, and it tells how good of a fit my data is. So let's write this down. So it said that my A value was 0.499. X, I guess you could round that to 0.5 also. And then the B value is minus 23.5. I'll tell you what, I'm going to go ahead and round that to 0.5. All right, so it says approximate the height of the student whose shoe size is 9. Shoe size, if you look over here on the table, is Y. So that means you know Y is 9. So you're going to do 9 in for the Y, and you're going to use the equation to solve and find the height. So first we're going to add the 23.5. I ran out of room, so I'm going to come over here. That's 32.5 equals 0.5x, and then divide by 0.5, and you're going to end up with 65. So it's 65 inches is about the height of a student who wears shoe size 9. So now C says predict the shoe size of a student whose height is 60 inches. Well, height is X, so that means if you know their height, you know X. So plug in 60 for X to the equation that we just got. And so we're going to have 60 gets us a shoe size of 6.5. So it says, is there a causal relationship in the data? So like, does the height cause the shoe size to be different? And I would say yes, because taller people have larger feet. Just in general, your height is generally related to your shoe size or to the size of your foot. Okay, let's go ahead and look at number 13. So number 13 says to evaluate the function when x is 0. So when x is 0, that goes with, here's a piecewise function right over here. It's in 2 pieces. So when x is 0, that goes with this domain. X is less than or equal to 0, because 0 is equal to 0. So we're going to use that equation, the 3/2 x plus 3. So that's the equation, and we're going to plug 0 in for x. So when we do that, we get an answer of 3. So now if you look at this one that says x equals 5, you look at this piecewise function and you find the piece that has a domain when x is 5. So I would say that that is going to go with this because x is greater than 0. 5 is greater than 0. So that tells me to use this equation. So I'm going to use the equation negative 2 times x. I'm going to plug 5 in for x, and my answer is negative 10. Okay, let's go ahead and look at the domain and the range. So the domain is how far left and right the function goes. So if you look at this function, it continues, as it goes down, it also continues left forever. So it goes to the left forever, that's negative infinity. And as this piece continues down, it also moves out to the right. So it goes to the right forever, that's positive infinity. So the domain, if it goes forever in both directions, you can do negative infinity to positive infinity, or you can do all real numbers. All right, now let's talk about the range. So on the range does not go up forever. It stops right here. It starts at 6, and that's the highest point, and it is a colored in circle, so it does include 6. Now, it does go down forever. So that's negative infinity is less than y is less than or equal to 6. You could also just say y is less than or equal to 6, meaning the graph only exists from 6 and below. Okay, let's look at this other one. So on this one, the domain, how far left it goes and how far right it goes. As it goes down, it goes to the left, and as it goes up, it goes to the right. So it goes forever in both directions, so the domain is either negative infinity to positive infinity or all real numbers. Either way is okay. Now the range, it also goes up and down forever, and so the range is negative infinity to positive infinity or all real numbers because it also goes up and down forever without stopping. Okay, these are extra review problems. All that means is I've gone out specifically to find them. So if I've gone out specifically to find them, they're probably fairly important. So the first thing it wants to know is write an equation in slope-intercept form of the line that goes through these points. So you find the slope with y2 minus y1 over x2 minus x1. All right, so that ends up being negative 1/3. And then you use the method you like. So if you're my people that prefer to start in points in slope-intercept form, y equals mx plus b, or if you're my people that prefer to start with point-slope form, that will work either way. You don't have to do both, just do one or the other. I'm going to use this point, negative 3, 2, as my point. So 2 is y. My slope is negative 1/3. X is negative 3. So if I do this, feel free to use a calculator as needed. This one I get 1 plus b, subtract the 1, and I find that b is 1. So my equation is negative 1/3 x plus 1. We've done a lot of these this chapter. If you like point-slope form, then you have y minus 2 equals, your slope is negative 1/3, x minus negative 3 becomes plus. Now distribute your negative 1/3, so you have negative 1/3 x. Negative 1/3 times 3 is negative 1. And then add the 2 back over, so you get y equals negative 1/3 x plus 1. So same answer, it's just two different methods. You just have to do the method you chose. Remember, we learned them both, but you do the one that you chose. Okay, number 10 is asking us to make a scatter plot of the data and describe the correlation. So we have advertising dollars as x. This is going to be my x-axis. And if you look, it tends to go up to like 4,000. So I feel like maybe going by 500s would be good. So that's 1,000, 1,500. This would be 2,000, 2,500, 3,000, 3,500, 4,000. And this is the advertising dollars. And then my y-axis is my yearly attendance. And let's see, my highest amount I need is 1,100. So I would say probably going by 100s would be okay. 200, 300, 400, 500, 6, 7, 8, 9. This would be 1,000. All right, and this was attendance. Not just attendance, I guess, but yearly attendance. All right, how many people attend a year to this neighborhood festival? All right, so your scatter plot, you're just going to quickly go, and you have the first point is at 500, 400, and then 1,000, 550, 1,500 was also at 550, 2,000 was at 800, 2,500 was at 650, a little bit of a dip that year. 3,000 was back at 800. 3,500 was at 1,050. And then 4,000 was at 1,100. So that's my scatter plot. My correlation, it's going up. As you look at it, it slopes up, so it's a positive correlation, and I feel like it's fairly strong. It's not a perfect line, but I would say like kind of medium strong. Like it's not bad at all. There's definitely a correlation. I don't think it's the strongest thing because the more they fall in a line, the stronger it is. So I'd kind of say medium strong. If you look at my answer key, see what I had put on there. I felt like so medium positive, so I was kind of iffy about it. You can tell I did a different, I ended up over here going by different amounts instead. So I went by 50s instead of 100s and drew a break in the graph. So, okay, let's look right here. It says, write an equation that models the attendance as a function of the amount spent. So you need an equation that goes through that line. It should have about the same number of points above and below. And it should kind of, go through generally in the middle. So you're going to take a ruler or a straight edge of some kind, and you're going to draw in a line. I'm going to kind of wiggle mine around here. If I do it right here, I've got about 4 above and 4 below. I think that's good. Now, you pick 2 points. They have to be on the line. It's okay if they're not points of our scatter plot, just points on the actual line itself. So like right here, this point was not on our original data, but we're going to use it. It's 2,000 and it's 700. So we're going to use that point, and we pick another point pretty much on the line. I feel like right here it's going to go through this point, and that is, let's see here, 4,500, 5,000. So this is 5,000, and how high it is 1,200. So those are the 2 points I'm going to use to write my equation of my line. So let's just go down here and write them down. So it was 2,700, and then it was 5,000, 1,200. All right, so first find your slope. All right, so I get 500 over 3,000. All right, which I'm just going to put as a fraction. It's 1/6. And then I'm going to just choose if you want to do y equals mx plus b, or if you want to do y minus y1 equals m times x minus x1. Either way should be okay. I'm going to do point slope form this time. So when I distribute the 1/6, I'm going to do 1/6 times 2,000. All right, that's about 333. And I'm going to add the 700. So I get y equals 1/6 x all right, which is, when we add that, plus 366.7. I'm just going to round it off. So that's the equation that models the attendance as the function of how much we spent on advertising. So the slope, when you see 1/6, 1 is the y, and that was the attendance. And 6 is the x, and that was money. So basically, you get one more person for every $6 spent on advertising. And what the y-intercept is the y, think of it like this point, 0, 366. So that means if we spend $0 on advertising, 366 people will attend. So if you spend no money on advertising, you will still have an amount of 366 people attend the festival. Okay, this says, consider the data in the table in exercise 10. Use a graphing calculator to find the equation of the line of best fit. I'm going to pause and work my way through putting that in the table. Okay, so all my data's in, so I go stat, over to calc, and down to the 4th row, which is linear regression, and hit calculate. This will give me my equation. Alright, so my equation is y equals 0.19x plus 309 if I round off.